Hello everyone. Let us continue with the previous session wherein we were trying to learn Hive and we were comparing Hive with the traditional databases. So let us quickly look at Hive resembles the traditional databases in many ways. Number of architectural differences are there. Now the limitations have been removed. So they are more or less similar, resembling completely. Now let us try to see where exactly do they differ. Schema on read versus schema on write. In traditional database, a table's schema is enforced at the data load time. If the data being loaded doesn't conform to the schema, then it is rejected. This design is sometimes called schema on write. Let me talk about I don't want to simply go to that. I want to explain what exactly is schema on write. Normally in SQL, what exactly do we do first? Do we create the table or do we insert? Which statement is executed? Insert, update, delete, whatever are the three statements. Let me take create table as one and insert as an example. Which one do we do first? Do we create the schema first or do we insert the data first? Obviously, we first create the table, that is the outline structure of the table, then we try to insert data into the table, right. So, we call this feature as schema on write. So, before I actually do some writing onto the table, we create the schema. This option is called as schema on write. This actually happens in traditional database systems. Whereas in Hive, the schema will be coming into action only when you are trying to execute some queries, when you are trying to load the data into the file. What happens in traditional databases if the data which we are trying to insert doesn't conform to the schema definition, doesn't match the schema definition? You will get an error. Sorry, I cannot insert this row into the table. Whereas in this, what it will try to do is, it will check against the schema. It does not verify it, simply it will try to load, but actual difference you will find out when you are trying to read data from the Hive table. So, traditional databases, they go with schema on write, Hive goes with schema on read. Until you are accessing some data using Hive query language, it will not try to load the data, it will not try to define the schema also. As I already mentioned, updates, transactions and indexes, these features are still not prevailing in Hive. Now, schema on write, which is followed by traditional databases, it uses the schema whichever is defined by the user and it creates a database according to that particular schema, then loads the data and data must conform to the schema definition. I just put all the things into one table. And schema on read, which is followed by Hive, data is loaded into a file using the file's native format. Data is not checked against the schema until you are reading through a query, and users can apply different schemas to the same data set and fast data loads, but as you know, slower query execution times. And to mention, this schema on read and schema on write is very important when you are attending any interviews or you are attempting any examination. They try to question you mostly on schema on read, schema on write and schema on read. What exactly are they? Then various data types, just like when you learn SQL, you talk about various data types like number, int, float, various data types are there. If you go to MySQL, the data types are slightly different, but you have some fixed data types which are built into the language. Hive query language also has primitive data types as well as complex data types. Let me show you all these data types which are prevailing in Hive query language. So, we have Boolean with integer only. If you see how many options are there, 4 options. tiny integer, small integer, integer, big integer. If you see, that is how they differ using the size. Tiny integer is of 1 byte, that means 8 bits, which is taking signed values, so minus 128 to 127. Similarly, small integer is 16 bit, which takes just like our C language integer. Int 4 byte integer, similarly big integer. This is how you try to define them. And what is the example? I want to give 1y. 1y is the tiny integer, 1s. So whenever you are working with tiny integers, you need to suffix it with y. Y stands for tiny integer. And float, how many options are there in float? Float, double, decimal. There are 3 options in float. So whichever is your requirement, you can try to use them. Then you have the options with string, varchar, character. These are dealing with character data types. You want to work with binary data type. Generally, binary data type is not supported here. When you work with SQL, earlier versions used to support something called as BMP, which suppose I want to store a BMP file, we used to go for binary data, raw data type was there. Now timestamp, I want to maintain timestamp, date, time in seconds, hours, minutes. Likewise, you can go for the timestamp data type is there. Similarly, date. So more or less some of the data types are common to SQL and Hive query language. Now apart from this, these are the complex data types that are available in Hive query language. Under complex data types, you have array. Array, the same definition goes with an ordered collection of fields, and the fields must all be of same data type. Our regular array definition, array is collection of similar type of data items. The same definition prevails here. Apart from this, you have map, which is of key value pairs. Structure is there, which we use in C language, structure to give collection of various fields. Similarly, union is there, wherein you try to define C like union, a value which may be one of a number of defined data types. The value is tagged with an integer representing its data type in the union. So you are trying to work with various complex data types, arrays, maps, structures and unions. Then how do we work with primitive data types? I have just given the list of primitive data types. Floating point. Apart from this, these are the character data types. So these are various complex data types. If you try to see for an example, the complex data type, we are trying to create table, complex, C1, first one is an array of integers, next one a map of string and integer, next one is a structure of 3 items, the next one is a union of type 2. So you can try to use whichever data type you want matching your requirements. And what type of operators can we work in Hive query language? So the usual set of SQL operators are provided here, like relational operators. You can check X is null or not. You can use the like operator, just like pattern matching kind. So you can use the like operator, arithmetic operators, plus, minus, asterisk, slash. These are all various division of arithmetic operators. Apart from that, you have logical operators like and, or, not, relational operators, greater than, less than, all these things. So whichever operators are prevailing in SQL, the same operators are prevailing in Hive query language also. Then the operators match those in MySQL which deviates from SQL 19, because double pipe sign is logical OR for us, and some languages they use it as string concatenation. In whenever you are working with MySQL and Hive, you directly use the concatenation function instead of the double pipe sign. And Hive also comes with a large number of built-in functions. Still, if you are not happy with the available built-in functions, we always have an option of creating user-defined functions. Now, how do I try to find out, how do I give the syntax of a particular function? Say for example, I want to find out what exactly is length function doing. What is the definition of length function? You can say describe function. What is the name of the function I want to know? Length. The moment you give this statement describe function, any function name, it will try to say length. What it will do? Length function will expect one of the parameters. What is the parameter? Either string or binary. So, length is a function which is expecting one of these parameters, and what it will return? It returns length of the string or number of bytes in the binary data. So, you can use this describe function in order to know what that particular function is doing, how many parameters. It is like help, right? So, in this case, when there is no built-in function that does what you want, you can always write user defined functions. And apart from this, type conversions, what are the conversions that are possible in SQL are listed out here. The implicit conversion rules are summarized as follows. Any numeric type can be implicitly converted to a wider type or to a text type. Any integer can be considered as a string, varchar or character. All the text types can be implicitly converted to another text types. They can also be converted to double or decimal. Boolean types cannot be converted to any other type, and they cannot be implicitly converted to any other type definitions. Similarly, type, timestamp and date can be converted to text. So, various typecasting options are displayed here. And always whenever the typecasting fails, the expression always returns a null value. Thank you. These are some of the type conversions available in Hive query language.